Hello dear students, welcome back. We were discussing about electromagnetic induction, isn't it? So what was electromagnetic induction? Electromagnetic induction is the phenomenon of production of current from magnetic effects or by changing the magnetic flux, that is total number of magnetic field lines associated with the coil. If you are changing the magnetic flux associated with the coil, an induced current is formed in the circuit. This is called electromagnetic induction. Now we are going to discuss about two laws that is given by Faraday to this electromagnetic induction. First one is that an induced current or potential difference is made in the circuit as long as there is a change in the magnetic flux, and if there is no change in the magnetic flux, no current or potential difference is induced. What is the first law? The change in magnetic flux induces a current or potential difference. And this current or potential difference it will last there itself until there is change in the magnetic flux. When the change in the magnetic flux is zero, no current is there. So until the change keeps on, the current is induced in the circuit. That is Faraday's first law. Faraday's second law, that is about the induction of induced potential difference or current, that will long as there is a change in the magnetic flux. Second law says that is second observation. Actually, it is a type of observation by Faraday. He observed that electromagnetic induction or induced current, its magnitude is directly proportional to the rate of change of magnetic flux. Rate of change of magnetic flux, that is represented by using the letter phi. It is known as phi. It's written so, phi. So what is meant by magnitude? Measurement, how much the current is. So the measurement of the current get increased if the change in magnetic flux is increased. If the change in magnetic flux is so vigorous, then what happens? More current is produced, as well as it depends on the time also, that indicates by the word rate. Rate of change means time. If it is happening, the change is happening in a very short time, that means more current will be induced. If the same change is happening in a very long time, that is, if it is a slow process, what happens? Less current is induced, and if it is happening more speedily, then more current is induced. So magnitude depends upon the rate of change of magnetic flux. These are the two laws by Faraday. And what happens, do you remember Fleming's left hand rule? So Fleming conducted some studies after Faraday's introduction of this electromagnetic induction, and he conducted an experiment using a galvanometer. Galvanometer is used to detect the direction of current, and to that galvanometer he connected a battery, and he noted the direction of current from where it passes to where. And after that, he introduced a magnet nearby to the coil. He took down the cell and he introduced a magnet, and he moved the coil backward and forth, and he observed the direction of current by looking into the galvanometer. Either it is in the left or right direction, we can identify the motion of current. So by looking into the direction of galvanometer needle, he found out the direction of induced current, and he found a law for finding the direction of induced current, that is known as Fleming's right hand rule. It's very easy. Do you remember Fleming's left hand rule? What was that? You stretch your left hand as such that the three fingers, forefinger, middle finger and thumb finger, are proportional to each other, are are perpendicular to each other, sorry, not proportional, perpendicular to each other, then central finger gives the direction of current, forefinger gives the direction of magnetic field, thumb finger gives the direction of motion or force, isn't it? Similarly, take your right hand, stretch your right hand such that thumb, forefinger and central finger are perpendicular to each other, then thumb finger gives the force and forefinger gives the direction of magnetic field and middle finger gives the direction of induced current, not current, it is induced current. That is Fleming's right hand rule. Fleming's So it's Fleming's right hand rule which gives the direction of induced current or electromagnetic induction. It gives the direction of induced current or EMF, electromagnetic induction or electromotive force. So that's all about today's topic. I think it's very easy, just two laws and Fleming's right hand rule. Thank you for watching. Have a nice day.